Here's an example of calculating beam reactions for a simply supported beam with two forces, a 10 kilonewton and a 6 kilonewton, and a UDL, a uniformly distributed load, which could be the weight of the beam, and that load is 2 kilonewtons per meter, which means for every meter there's 2 kilonewtons of force. So that is in green, and two forces, 10 kilonewtons and 6 kilonewtons coming straight down. One is 6 meters in, and the sixth one is 3 meters from the 10. The beam is 12 meters long, and we've got to work out the beam reactions. So we've got to work out, there's a reaction there, we'll call that RA, reaction A. And there's also going to be a reaction there, which we'll call RB. Point B, point C. So, simply supported beam, two reactions, point A and point B. As normal with these problems, a moment is a force times a distance. Force in newtons, distance in meters. We've got to make some assumptions. The sum of the moments equals 0. This beam is in balance, so when you add up all the moments, they've got to equal 0, so there's no bending, no twisting, and no got our balance. So all the moments have got to equal 0. The sum of the forces have got to equal 0, which means what goes up has got to come down. So this beam is in balance and it's straight. Sum of the forces equals 0, and I'm going to call clockwise moments positive, and I'll call anti-clockwise moments negative. Because we're going to be doing moments, so I'm going to state that everything going clockwise is positive, anything going anti-clockwise is negative. They're my assumptions. Before we do anything else, must be point A there. Anything else? Before doing anything else, I need to convert this. Need to convert that UDL into a point load. So the first thing I'm going to do is convert UDL into point load. The reason I'm doing that is because it makes it easier for us. I can then treat it as a point load like the 10 and 6. So I can use my formula. So to convert my UDL into a point load, all I'm going to do is multiply the UDL by how much it acts over. Our beam is 12 meters long, and we've got 2 kilonewtons per meter. So I've got 2 kilonewtons per meter, and it's over 12 meters. So 12 times 2 will give me 24. Don't forget to put the K back in. 24 kilonewtons. So that UDL is equivalent to a 24 kilonewton point load. And as always, we put it in at halfway along the beam. Halfway along where the UDL acts. Halfway along where UDL acts. In this case, the UDL is across the entire length of the beam. So my 24 kilonewtons will be placed at obviously 6 meters. My pen works. So it's going to be 6 meters. I'll just say from the left because it's left or right, isn't it? So I now got 10 kilonewtons, 6 kilonewtons, and I've got 24 kilonewtons at 6 meters from the left, which means we're going to have two forces now at the 6 meter mark. So I'll just redraw what it looks like really. So here's my beam. Quickly draw it again. That's my supports. I've got a force Got my 6 kilonewtons there, same distance. I've got my 10 kilonewtons there, they haven't changed. I've also got now this 24 kilonewtons at 6 meters from the left. So I'll put it down here because it is in line with that, because this is 6 meters and that there's 3 meters. So my UDL force, I'll change the color. My UDL force really is going 6 meters in, so it's going here as well. So I just draw a line like that because that's where it is, so we don't forget it. 24 kilonewtons. So that's got rid of the UDL. So now I've got 3 forces, a 10, a 24 and a 6. I've got to work out that reaction A and reaction B for this beam. So we're still going to use moment, force times distance. Sum of the moments equals 0, sum of the forces equals 0, anti-clockwise negative, clockwise positive. So I'm going to call this point here, point A is my pivot point. So that's my first thing I'm going to be doing. So I'm going to take moments about point A, about point A. So that's my pivot point, and I'm going to be taking moments about that point. So a moment is a force times a distance. We all know that. So my first force is the 10. So there's my 10. So that's my force, 10. I'm going to leave the K out and put it in at the end, so make it a bit easy for us. 10 times, how far is that 10 from here? So there's my 10 and it's 6 meters away from there. So it's going to be 10 times 6. 10 times 6 is going to be my first moment. There's my 10, there's my 6. Excuse me. It's going clockwise. It's trying to go like that. It's trying to go clockwise, so it's positive. So I'll leave it as a positive number. My next force while I'm there, I've got this 24. This one is by 24, is the UDL one. So that's also going clockwise. It's also going clockwise, so I'm going to put a plus. 24 is my force, and that force is also 6 meters from this point. 24 times 6. Oops, 24 times 6. So that's my moment due to that force. Going clockwise, so it's positive. I've also got this force here, the 6. That's also going to push this beam clockwise, so I'll put a plus there. My force is 6, and it is, how far is that 6 from my pivot point A? 6, 7, 8, 9. So 6 times 9. Come on, work. 6 times 9 is my moment due to that 6, and it's 9 meters away from my pivot point. Going clockwise, that's why it's positive. So I've got 10, 24 and 6. So there's my moments due to them forces. I know them ones. I've also got this reaction here. This is also a force. We don't know what it is. We're trying to work it out. So this force here is trying to make this beam go trying to push it that way. When this pen works. It's trying to push it that way, which is anti-clockwise, about this point here. So it's going to be a negative number. So RB is a force, we don't know what it is. We put it in, we're trying to find what it is. RB is the reaction times by the distance. How far is this force from my point A, well, it's 12 meters, because the length of the beam is 12, times that by 12. Put a little bracket around it. So there are my moments. I got 1, 2, 3, 4 forces and 4 moments. Like we said before, sum of the moments has got to equal 0. So all of this has got to be equal to 0 for this thing to be in balance. Next thing to do is work out all of this. So if you add all of these up, you will find that you get 258 minus RB times by 12, all still equals 0. So 10 times 6 plus 24 times 6 plus 6 times 9 gives you 258. I'm going to now move the RB, I'm going to move this negative term over here. So I'm going to leave the 258 there, and I'm going to take the RB times by 12 across, making it positive. I've just taken this negative term over to this side. 258 equals RB times by 12. And now simply to find RB, all I've got to do is divide both sides by 12, which means I'm doing this. 258 divided by 12 equals RB times by 12. Just do it all the way through. So to get rid of the 12, I divide both sides by 12. Really, that 12 and that 12 cancel out. So now I've got 258. Different color, perhaps let's do red or something. So now I've got 258 divided by 12 equals reaction B, which if you put into your calculator is 21.5 kilonewtons. So the reaction at RB is 21.5 kilonewtons. Thank you very much. So we've done that one. I'm going to do RA. So with RA, I'm going to make this the pivot point. So I'll change the pivot point to point B now, because we're trying to find RA. Still the same method. Obviously these now are going to go, these forces are going to go anti-clockwise, so we're going to have some negative numbers here now. But all I'm doing now is swapping over. So I'm going to calculate RA, and I'm going to take moments about point B. So my first one is going to be this 6. Let me get close the things up a bit. Get rid of some of this. Get rid of that bit there, that bit there, that bit there, and that bit there. So there's my pivot point. There's my 6. So 6 times by that distance in there was 3 meters in there. So my moments are going to be the 6 times by the 3, because it's 3 meters from there. I've got 10 times by 6, because it's 6 meters from there. And the 24 is also going to be 24 times by 6. They're all going to be anti-clockwise, because it's trying to push this beam anti-clockwise. And don't forget, I got RA over here, which I'm trying to find. RA is trying to push this beam clockwise. That's going to be a positive number. and it's 12 meters away because the length of this beam is 12 meters. So that's what I'm doing. So my first one is going to be 6 times by the 3. So I've got 6 times by 3. There's my 6 and there's my 3. The 6 is 3 meters away from that point. It's going anti-clockwise, so I'm going to put a negative number in there. We're still doing this. Sum of the moments equals 0, so we're adding them up. Plus. The next one is going to be that 10. So it's going to be 10 kilonewtons times by 6. It's 6 meters away from there. It's going anti-clockwise, so I'm going to put a negative number. So 10 times by 6. Anti-clockwise, put a negative number in there. Sum of the moments, there's one more to add. This 24, the UDL one. So 24 kilonewtons, and it's also 6 meters from this point here. Also going anti-clockwise, so I'm going to do 24 times by 6. Anti-clockwise, put a negative number in there. That's the 3 forces that we know. The next one is to do RA here. We don't know what it is, but we know it's 12 meters away from point B and it's going clockwise. So we're going to be doing plus, because clockwise, plus. We don't know what it is, RA. We know it's 12 meters away. 12 for some distance, and all of that has got to equal 0 because the sum of the moments have got to equal 0. If you add all of these up on your calculator, don't forget you've got minus numbers here, so put minus 6 times by 3. Make sure you include the right brackets. Add them all up and you get minus 2, 2, 2 plus RA times by 12 equals 0. So as before, I'm going to take this over here. It's a negative number there, so I'm going to bring it across and make it positive. So I get RA times by 12 equals 2, 2, 2. Because it's a negative number there, and you've got to add it to both sides. So RA divided by 12 is 2, 2, 2. And like in the previous example, I'm just going to divide the 2, 2, 2 by the 12. So RA is going to be 222 divided by 12. Put that in your calculator, you get 18.5 kilonewtons. So RA is 18.5 and RB is 21.5. So 18.5 is over here. 18 point, don't forget the kilo. So that's working out the reactions using moments. We can check that. We can check it. The last bit we'll do, we can check it because we know that where are we? The sum of the forces equals 0. Let's get this pronounced right. So the sum of the forces have got to equal 0. So whatever comes down has got to go up. So we know that we've got, I'll just make this a bit more. We know that we've got, I'll get rid of all this because we don't need that anymore really. We know that we've got 10, 6 and 24 coming down. So that's the forces coming down, and we've also got RA and RB coming up. So I'll do it here. RA, plus RB, they're the ones coming up. They've got to equal 10 plus 6 plus 24. And for this beam to be in balance, RA plus RB has got to equal 10 plus 6 plus 24. Now 10 plus 6 plus 24 gives you 40. So RA plus RB has got to equal 40. Now we know that, just make some room here. We know that RA is 18.5 and RB is 21.5. So if you add them together, so 21.5 plus 18.5 gives you, have a guess, 40. Have a guess kilonewtons. So we know we're correct because we know we've got 40 coming down. There's 40 coming down and there's 40 coming up. So the beam is in balance. Thank you very much. Thank you very much. That's one way of doing it. It's the best way to do it. I mean, what you could have done is this. I'll squeeze it on the end. Once you've worked out RB, so once you know that RB is 21.5, you could have added up all the forces coming down, 40 coming down. You could then take away RB, which would leave you with 18.5, which is RA. Don't forget the kilonewtons. So you knew 21.5 was coming down, sorry, coming up, because the direction's coming up, and there was 40 coming down. So if you take away 40, take away 21.5 will give you 18.5. You can't do it that way. The only problem with doing it that way is if this 21.5 here was incorrect, that there would be incorrect. So the best way to do it is do it like I've done. Take moments from both sides, point A and point B. The only thing difference is you're going to get anti-clockwise and clockwise on each side. And then just to check, just add them both up. So like 21.5 plus 18.5 gives you 40. And then just check that there was 40 coming down, which there was in my case. So that's calculating reactions on a simply supported beam with 2-point loads and a UDL. Hope that helps a bit. Over and out.